everyone. Today I'm presenting my homework. Find the block degree from the signal flow. In this presentation, I will first introduce the program's statement. Then I will analyze the signal flow graph step by step. After that, I will write the node equation, expands the physical meaning, and finally solve the requirement block degree. Now let's begin with the program statement. This side show the program statement. The test is to find the equivalent block degree from a given signal block graph. In this graph, the input is xs, and the output is y of s. There are also two important intermediate nodes, which are E of S and C of S. The graph include a forward gauge of S, a feedback branch negative HS, and a disturbance input NS. So our main goal is to understand the relationship among this signal and then convert the signal flow graph into a standard block degrees. On this side, I identify the main branches in the signal flow graph. First, xs goes to es with k1. And then es goes to cs through gs. Third, cs go to ys with gen1. In addition, ns enter the node c of s with gen1. Finally, there is a feedback path from CS back to ES, and gen is negative HS. By reading this branch carefully, we can write the node equation of the system. Based on the signal flow graph, we can write the node equation. The first equation is ES equal X of the XS minus HS times CS. The second equation is CS equals GS times ES plus NS. The third equation is ys equals cs. This equation describe how the input signal, the feedback signal, and the disturbance signals are connected in the system. This slide explains the physical meaning of the equation. The signal X as enter the system as input. Then the feedback signal in subtracted from the input, and this cues the error signal ES. Next, the error signal passes through the forward block GS. After that, the disturbance input NS added to the system. Finally, the output signal is YS. So this system can be understood as a negative feedback control system with an extended disturbance input. Now I will explain how to construct the equipment block during step by step. First, the join of the following paths from the input or to output. The input produces the error signal ES, and then ES passes through GS. Second, we add a feedback loop. The output signal is feedback through HS and suggested at the summing points. This creates the negative feedback status. Third, we add the disadvantage input N of S NF before the output. In this way, the complete equivalent block degree is applied. This side shows the final equivalent block degree. From the degree, we can clearly see that the system has one forward pass, one feedback pass, and one disturbance input. Disturbance input. The error signal is formatted at the first summary points. Then it passes through GS. After that, NS is added before the final output YS. Then my equation of the block degrees are ES equal XS minus HS times YS, and the YS equals GS times ES plus NS. Therefore, this block degrees is fully equivalent to the original signal flow graph. In conclusion, this program was solved by converting the signal flux graph into an equivalence block degree. First, I identify the branch gains in the graph. Second, I wrote the node equations. Third, I interpreted the physical meaning of resistance. Finally, I constructed the equivalence block degrees step by step. This means useful in control system analysis because it helps us understand the uh, structure of the system more clear. Okay, this is the end of my presentation. Thank you for your listen, and see you next time.